let us start the second chapter. Okay, that is electric potential and capacitance. Electric potential and capacitance. Okay, so all of you must be enjoying the lockdown. I am also enjoying the lockdown, teaching in front of this camera. No students at home. Anyways, this is only dedicated for all of you, those who are in lockdown, those who have finished chapter 1. So this is for those who have finished chapter 1 and started chapter 2. So this is electric potential and capacitance. So before going into the capacitance, first of all I have to know what is electric potential, and I believe that you must have studied electric field in chapter 1. Okay, so electric potential and capacitance. Now electric potential is simply the work done, okay, work done in bringing a test positive charge from infinity to that point. Here that point means the point at which I want to bring that. Where is the diagram? So what happens is, let me have a charge particle here, Q. Okay, so it is just sitting here and I want to bring this here. Okay, I want to bring this here at point P. Okay, and please remember this region is electrostatic. This is electrostatic region. Okay, electrostatic region. So this is electrostatic region and this is Q, where is very at infinity. Infinity, which is not experiencing electrostatic field because of some charge. Okay, there is so many electric field in this region. Now what you do, you bring this charge from this infinity to this point. So you are bringing, okay, so you are bringing what? You are bringing a positive charge from this infinity to this point, and what you have to do is you have to work. Okay, whenever you bring this charge, you have to work with the charge. You have to do some work. So you are doing work. Okay, you are doing work in bringing this charge from infinity to this point, and this work is done to bring this charge. Work done for this charge. Okay, you are doing work for this charge is equal to electric potential. Very simple. Work done in bringing this charge, okay, from infinity to that point in an external electrostatic field, or you can also say electric field. So you are bringing charge, bringing charge, doing work, and work divided by Q is my electric potential. So the formula for electric potential, this is denoted by V, which is equal to work done. Okay, work done divided by charge. Okay, work done divided by charge, and its SI unit is Newton meter coulomb inverse 1, or simply volt, V. So both are same. The potential difference has got the SI unit volt, and electric potential is also have the same SI unit volt, or this can also be written as Newton meter per coulomb. So this is very simple. Electric potential is the amount of work done in bringing a positive charge from infinity to that point in an external electrostatic field. So this is very simple, and please remember the work has to be performed in or against the electrostatic field, and that electrostatic field could be because of so many charges, some source charges. So that is the thing. Now let me go to the electric potential due to point charge. Electric potential due to a point charge. How much is the electric potential due to a point charge? Okay. So let me have point charge. You must have understood. Okay. Point charge. Point charge. Let me say this as my Q. Point charge. Okay. And I have a test charge Q0, okay, at infinity, okay, and it has got electric potential, say somewhere here, from which it is not producing any electric field here. It is only producing electric field up to this region. Okay, since this is very far away. Now I want to find how much is the electric potential of this charge. Okay, of this charge. It is a positive charge. This is also a positive charge. Now again, what I need to do? I have to bring this charge, test charge. I just want to bring this charge against the electric field of this electrostatic field of positive charge, test charge. I mean against the source charge. Source charge. Okay. Now I will bring it from infinity. I will bring it. Okay. And bring it here. And I will bring it here. I reach here. And let this distance be my R. Okay. So this distance is my R. Now this is here. What I am doing here, I am performing small work done. Okay, small work done. I am bringing this Q0 from infinity. I will bring it first here. I will perform a small work dW. I will from this I will move here. Small work. From this I will move here. Small work. Okay, I am doing small work, and finally it has reached this. Now I am working against the electric field of source charge. Okay, by definition, what is the formula of electric potential? So electric potential formula is V is equal to work done by charge. Okay, I am doing work to bring which charge? This charge or Q0? I am bringing Q0, so I have to write here Q0. I am working against the electric field of this one. So this is my from formula, but I want to have the expression for electric potential due to this charge. Okay, so I have to find what is work done, right? So how much is work done? You know, work done is equal to force into displacement. Okay, force into displacement. So you can always write a small dW. Okay, this is dW and this is this small displacement. Okay, you can also do like this. Now small displacement will give me R. Okay, let this with R. Whenever you want to bring this from Q0 to Q, you have to do a small dr. Okay, small dr, and if you get all, then you will get total. So what I do here is I will just write the work is equal to force into R. I am not doing a small r. I am just directly saying it is the total distance R. So how much is the force? Coulomb's law from first chapter. Coulomb's law, we know that force is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, I am finding work done. So let me write this one. How much is the force? It is 1 by 4 pi epsilon naught Q1 के जगह पर हमारा है Q0 and instead of Q2 I have got Q. Please remember this one. Q1 is my Q0 and Q2 is my Q divided by R square distance. Okay, and into one more R is there. This R is there, so into R, this R and this R cancel. So what do I get is I get work done is equal to 1 by 4 pi epsilon naught Q0 Q by R. If I get the work done, then if I put this work done here, I will get the potential. Very simple. Work done is force into displacement. Force is this. Displacement total will be R. Okay, if you bring this Q0 from this to this. Okay. There is one more very important point in this. Okay. So, if I put this work done here, then I will get V is equal to, what is work done is 1 by 4 pi epsilon naught Q0 Q divided by R square whole divided by Q0, and this Q0 will cancel this Q, and I will get V is equal to 1 by 4 pi epsilon naught, not R square, only R, Q by R. So this is the electric potential due to a point charge. Very simple. So now from this, okay, from this there will be one question in board. Very important question. Very important question. Okay. So you have to remember this V is equal to 1 by 4 pi epsilon naught Q by R. Okay, these two formula very important. Okay, so you have to remember. And now in electric field there was R square. In potential there is no R square. Okay, so it is all the things are very similar with electric field. Electric field will have 1 by 4 pi epsilon naught Q by R square, but potential don't have R square. Okay, so this is how you can remember. Now here the most important thing is the limit Q0 tends to 0. Significance of this, very important. Here whenever I say this, okay, whenever I say that V is equal to work done by Q0, then this should be limit Q0 tends to 0. It is very important. It means that this Q0 should be vanishingly small. Very important. Its significance. Sometimes it is asked what is the significance of limit Q0 tends to 0. It may have some other form also, but whenever you see this one while calculating the electric potential, you have to remember, you have to say this one, Q0 is very small. Why it is very small? Because see what we are doing here is we have this Q and we have this here, okay, somewhere here we had Q0. So whenever I bring this here, whenever I bring this near to this one, this is my source charge. Now whenever I bring this closer and closer to the source charge should not get displaced from its mean position. Please remember, because I want to calculate the electric potential due to this source charge. Now if it displaces, then my calculation will become wrong. Understood? So the electric potential, to calculate electric potential, this test charge should be very small, so that it do not displaces the source charge, because there is interaction between this charge and this charge. Coulombic force is always and always there, वहाँ पे वो है, लेकिन वो बहुत छोटा हो, इसलिए it has to be very small. So it, number one, Q0 is very small. so that the source charge the source charge do not get displaced. Very important 1 marks question. Why this Q test charge should be very small. Not only this, you may get limit Q tends to 0. This may get because I have considered test charge as Q0. Okay, so you can also consider as Q only. So it means that it should be very small so that the source charge do not get displaced, because we want to find the electric field due to source charge. So if it get deflects, if it displaces, how to calculate? Isn't it? It is very difficult. So the force to reduce the displacement, we consider this as very small. Jai Hind.